So addition and subtraction, you cannot combine unlike terms. Now, multiplication, let's do a problem with that real quick. So let's say we have a problem, again, 3x squared plus 4x. Oh, sorry, that's not what I wanted to do. Okay. Let's say we have a problem 3x squared, y cubed, z to the 4th power, times 2x squared, y, z, all raised to the 3rd power. Okay, now, with that being said, we have a different problem now. We have a different problem because of this right here. Okay, that multiplication now is a different problem, and we do a different process in order to solve this. You can do one of two ways. I can work the inside first. That's what I'm going to do. Work the inside first. 3 times 2 is what? 6. Okay, x squared times x squared is x to the 4th power. Y cubed times y is y to the 4th power. Z to the 4th power times z is z to the 5th power. All of that is cubed. Shh. Now,
so you distribute last after you do all that stuff?
You can do it either way.
Okay. Like you'll get the same answer no matter
Yes.
which way you start.
Okay, wait, why can you...
Okay, so he asked, why can I combine the 3 and the xyz and the 2xyz whatever on this one versus the other one? Why?
Because this is multiplication.
Yeah, but they're still in like terms though.
But they're still in like terms. But multiplying and dividing, you can do anything with any term. Adding and subtracting, you have to follow the rules of combining like terms or unlike terms, or not combining unlike terms. Okay?
And when adding and subtracting, when they have different exponents, they're unlike.
Right. If they have, so basically, if I have all the same variables, like here I have all the same variables, but if I had a plus sign there, I couldn't combine because I had different exponents.
So then that would be the answer.
Yeah, up there. Well, I'd have to distribute that 3 first, but yeah. But the point is exponent will make it an unlike term. X is not the same thing as x squared. Y is not the same thing as y squared. That becomes unlike. Okay. Now here we can continue on. Here I need to go ahead and distribute that 3 to everything again. And I end up with 6 cubed, x to the 12th power, y to the 12th power, z to the 15th power. And then I could work out whatever 6 times 6 times 6 is.
216.
Okay, 216, x 12, y 12, z 12.
15.
Sorry, 15. Thank you. All right.
Wait
So
a second. Why
yeah.
did you just do 216?
6 cubed.
Oh, yeah, okay.
Okay, so I wanted to show you the differences because what happened was, and this is why your grade struggled, because what happened is like Gage was saying, you're rolling through your homework and you're rolling through the classwork yesterday because the classwork was easier than the homework. So you're rolling through the classwork and you've got everything, you're feeling good about yourself. But then you get home and you get thrown that problem like this one where you have the addition, you get thrown that problem and then all of a sudden it's either A, you get confused, and you stop and you get confused, or B, you just keep rolling through like nothing and don't pay attention to this plus, and that messes you up. But you've got to remember back to the first 6 weeks, part of that was intentional. You should know not to be able to combine unlike terms. You should have known that. You've got to take it to the next step. That's how learning occurs, okay? All right, any questions on that? Because I want to show you a couple more things.
Wait, there was one on the homework. It was some like 7m.
Yeah, we'll look at 7a times.
Yeah, it was like they both had the same exponent, and like I didn't know if you add those two exponents together.
Okay, okay, look. There's a problem on your homework that looked kind of like this, and I can't remember what it was exactly, but it was 6m squared plus 4m squared. Okay, something like
I
that?
think it was
Yeah,
4m
yeah,
cubed.
something.
Okay, well, in the other case, no, it can't be. No, you're talking about the other one. He's talking about this one. Now here, what's happening? What's our major operation? We're adding, right? Which means I have to think about unlike and like terms. Are these like terms?
Yes.
Yes, they are, because you have m squared and m squared, right? So it becomes 10 m squared.
So you don't add the exponent.
No, because look at this. What if I gave you this problem right here?
Isn't it like basically adding two fractions?
What? Kind of, but you're reaching. Look at it like this. I see what you're saying, but I'm not going to put that out there. Look at this. What if I told you this? What if I said 6x plus 5x? What would you tell me the answer is? 11x. It's the same rule that applies to this that applies here. Notice it's not 6x squared. I'm sorry, 11x squared. It's 11x. Because when we add, it's just making sure we have like terms. You see, they're the same thing. There's no difference. And the reason I bring this to your attention is because we've been doing this all year. That's nothing new. When you throw a square up there, it doesn't change anything. Okay? All right. Now, I want to show you this too, because my second period, one of my students, they were having trouble with this. If you have this, 8m cubed, okay? Can I do anything with that?
No.
No. I'm done. I have people in my other classes that are trying to do this or this. You can't do that. Now, which is okay. I mean, I understand where they're getting at because they're getting confused with this. 8m cubed.
What about when there's brackets? Does that just mean dittos first?
Brackets, you're not going to see a whole lot in ninth grade, but that means it's just part of like a parentheses.
Was it like,
So-
does it come
Can you
before
do-
parentheses or-
It'll come after usually.
Can you do one of the ones on
Yeah.
the homework?
Yeah, I want to show you another one from the homework, but I wanted to show you this real quick. These are different. Okay, not the same. Okay, any questions on that? All right, now. There was a problem on your homework, and somebody that, well, I'll just do it. Well, yeah, I want to look at it.
I want
That's the one with the brackets on it?
this is the one that.
I want to show you this one too. Hang on. It goes with the same ones. Are you talking about this one with the brackets? 2x squared
Yeah.
The brackets just come first.
squared
So like in order of operations.
bracket.
Yeah, when you have to distribute to the ones in the bracket.
Okay, all you're doing, no, you work inside out. Okay? When you have this, you work inside out. So then this becomes what? 4x
That's what I.
to the 4th, right? Now you have still another square. So then it becomes not 8, 16 x to the 8.
Wait, so would I still get the same answer even if I went from, like if I distributed the 2 that's outside the brackets?
Well, they're all 2, so yes.
to one? Okay, cool.
But yeah, he's saying, what if I did this? Well, I guess you could. Let's go back.
No,
Hang
I
on.
mean that 2 to the one that's
Hang on,
in
yeah.
between-
I know what you're saying. Hang on. I guess if you did this, is it x squared inside too?
Yes.
Yeah, they're all of them are 2.
Okay, I guess you could do this, where you do right here.
Yeah.
You would have 2x squared to the 4th now, right? So now distribute this in here. So 2 to the 4th power is what? 16. Is that what we just got? X to the 8. So yeah, it works the same way. There you go. All right. What's another one you wanted to work?
On the last page or two now.
Like 9 or 7.
Yeah, okay, I want to look at 7 because that's the one I looked at in another class. So you have 7ab times 2a plus 4b minus 6. And again, this is, and you're going to find out all these are the same. They're really the same thing. Okay, you're just doing a little bit more. Ian. Okay. You have a major quiz on this tomorrow. And your major quiz grades from before, which I'm about to stick in there if I haven't, are not very good. You need to do well on this. And based on your homework, from the people who did the homework, not very pretty. So you need to hear this. Now, which is why we're not just jumping into the work like how I had initially intended to do. All I'm going to do is distribute this like normal. The whole thing. Distribute it. Okay, so 7ab times, and now look, I'm going to show you the long way, and this is what I did in my other class. I'm basically going to show you how you can do it the long way. You'd have 7ab times 2a plus 7ab times 4b plus,
No minus.
no, 7ab times negative 6. Right?
Yeah.
Okay? Because it's a positive 7ab. Again, that's the broken down way. I wouldn't do it that way because I could do this mentally, but if you need to do that, do that. All I'm doing is saying, okay, 7ab times 2a, right? There it is. 7ab times 4b, there it is. 7ab times negative 6, there it is on paper. So now I just work it out. So 7ab times 2a, 7 times 2 is what?
14.
14. A times a is? A squared. A times, I'm sorry, b and a, there's no more b's, right? So just bring the b down. Over here, so that's done. 7 times 4 is? 28. Okay, a times nothing is a, or 1. B times b is? B squared. Okay, 7 times negative 6 is? Negative 42. Okay, do I have a and a b to mess with? No, so just bring down a, b. So now look, do I have any like terms? Oh, a squared b, ab squared, ab, all different. I cannot go any further because, again, of these right there, those keep me from combining because they're unlike terms. So my answer is this right there. All right, any questions on that? Okay, we have any other questions on our homework?
Wait, so even if it's AP or whatever, you can still like, if it has an A or whatever, you can like combine them, like AP.
What?
I don't know.
You're not speaking clearly.
Like, if you had 14 AB, 6A, combine those.
No. Okay, listen. Here's what she's saying. What if I have 14a plus 6ab? They have an a, right? They share that common term, right? But what makes them unlike terms? The b right here. That messes up everything. So now they're not like terms. So that's the answer. You would stop right there. Does that make sense? That would answer your question? Okay? Even if part of it's the same, it's all has to be the same. Does everybody follow that? Okay? Part of the problem that we had with this particular unit, and I'm not a big fan of it, and I didn't realize this till last night, is that when I've taught this in years past, we teach combining like terms. Big time. For just a day. Doesn't take a lot to figure that out. But we go through a lot of weird numbers, situations where we show combining like terms. Then we get into this stuff right here. We never really had that unit where we did combining like terms because when we introduced combining like terms, it was just x and y. And that's obvious. You don't combine those. But when you have a bunch of stuff, it's got to be exactly the same. Anybody have any questions on this? All right.